Alright, as I mentioned in class on Friday, we're going to revisit some special right triangles, and we're going to get a little bit more in depth and a little bit more complex. Good thing is you guys had a pretty good feel for it, and you guys did actually a really nice job in the fall, so hopefully it comes back to you rather quickly, and then we can go from there. We're going to focus on pretty much what we did in the fall. We're going to throw in some extra word problems, but we're really not going to go any farther than what we did. So if you think you already have a pretty good handle for it, you might be able to do this entire set of notes by yourself. If that's the case, you can always skip ahead if you want and then see if you got the right answers. But do make sure you follow along, especially if you do need a refresher. So again, we're just going to look at some basic, simple, or special rights and some basic word problems. So a couple of reminders with radicals. Radicals are anything underneath a radical sign or a square root sign. First, we can only multiply the innies with the innies and outies with outies. Okay, belly buttons, if you want to think of it like that. Innies multiply together, outies multiply together, never combine them. We also want to make sure we never ever leave a radical in the denominator. Okay, again, things we've talked about before. And you saw in Algebra 1. We had two special rights. Again, there's not going to be any more. These are the only special rights. Okay. If you're given a 90-degree angle, you can use it. And if you have a 30-60 or 45-45-90, that's what you're going to see. You're only going to see these two. We know we can use Pythagorean theorem in other situations. But these are the two that we're going to focus on right now. Across from 30, we label as S. So if that was, say, 4. Across from 60 would be S radical 3. So that would be, say, 4 radical 3. Across from 90 would be 2S. So again, let's take an example of 4. So if that side's 4, this side's 4 radical 3, this side is 2 times 4, or, excuse me, 8. Okay, I will always use S's. S's are just a variable that we're using to represent the smallest side. And everything's based off that. 45, 45, 90, across from 45 is an S. Across from the other 45 obviously have to be S. Across from 90 is S radical 2. Okay, let's take the same example. If this was 4, so is this, and across from 90 is 4 radical 2. Basically, your 45, 45, 90 is a square cut on the diagonal. Your 30, 60, 90 is a rectangle that's cut, and it's not a perfect diagonal because one angle is 30, one angle is 60. Okay, so again, pay careful attention to the steps and the way I do it, because I will do it the exact same every single time. Let's look at the first one. I'll keep these up here so we can see them as we go. First is identify what kind it is. Well, it's a 45, 45, 90 because you can see the 45 degrees and the 90-degree angle. You also see that you have one given side. That should tell you you can't use Pythagorean theorem. So what we're going to do is go across from 45 and call this S. Across from 45, we'll call this S. Across from 90 is S radical 2. You always start where your information's at. Here's our information. So we have S radical 2 is equal to, S is equal to 5 radical 2. Okay, so there's our S. That's part of our answer. Now all we need to do, once we have S, again, we only find it once. Once we find it, we plug it back in wherever we want. So this side is just going to be 5 radical 2. And then over here with Y, we're going to have 5 radical 2, plugging it in for S, times radical 2. What that turns out to be is 5 radical 4, or 5 times 2, which is 10. So we have X equals 5 radical 2, Y equals 10. Okay, so again, locate your S, locate your information after everything's labeled, and then plug back in. Next one. We have a 90-degree angle. We only have one side, which means we can't use Pythagorean theorem, but we also don't have any angles labeled besides the 90. So how do we know if it's 30-60 or 45-45? Well, if you see these sides are the same, then it's a square. It's a square that's been cut in half on the diagonal, which tells you it has to be a 45-90. So across from 45 is S, across from 45 is S, across from 90 is S radical 2. Here's our information again. And now we're going to go ahead and set that up. S radical 2 equals 18. Divide both sides, so we're going to get some practice here. Can't have that in the denominator, so in that same step, I'm going to go ahead and multiply the top and the bottom by the square root of 2. So we get 18 radical 2 over the square root of 4. Any times any is still inside. So that's 18 radical 2 over 2, which ends up being 9 radical 2 for your s. And again, you're going to go ahead and plug that back in. This becomes an easy one. This side is just 9 radical 2. This side is just 9 radical 2. So x is 9 radical 2. Y is 9 radical 2. Moving right along. Same kind of idea, number 3. You have two sides that you don't know, so it's not Pythagorean theorem. You have a 45. 45, there's your freebie for your x. 90. Again, here we go. This is s radical 2. Across from your 90s is just s. Here's your information, so let's go on and set that up. So s radical 2 equals 18 radical 6. Not a big deal. Divide both sides by the square root of 2. Since you have an ini over an idi, you could actually do that in one step instead of worrying about multiplying top and bottom by square root of 2. Because 6 divided by 2 is 3. They stay inside, so this is just 18 radical 3. And you can do that as a nice little shortcut there. There's your s. Plug it back in. This side's 18 radical 3. So is this side. That's the nice part about your 45, 45, 90s. Is once you get s, you have both sides. Excuse me. Okay, 30, 60, 90. Mixing it up a little bit. Across from 30 is s. Across from 60 is s radical 3. Across from 90 is 2s. Here's your information. S radical 3 equals 15 radical 2. Divide both sides. And here's where you do run into the issue because 2 over 3 can't be reduced, so we do have to do the long way here. Multiply top and bottom. So we have s equals 15 times the square root of 6 over the square root of 9. Any times any on the bottom is still inside. So that's 15 radical 6 over 3, or just 5 radical 6. You can always deal with outies. 15 divided by 3 is 5. Always deal with innies separately. So there's our s. Let's go ahead and plug it back in. This side is 5 radical 6. And then down here is 2 of those 5 radical 6s. So we have 10 radical 6. 2 times 5 is 10. Don't multiply 2 times radical 6. That stays separate. So again, x is 5 radical 6. Y is 10 radical 6. Moving right along. So there's our simple basic setups. Again, some trickier radical stuff in there. If you need help with that, make sure you come see me or ask a question in class tomorrow. 5, 6, and 7, we have some word problems, and then we'll be done. So not too long. You've seen these kind of word problems before. A square, okay, has a diagonal of 11 feet. Find the perimeter of the square. Well, we need to know one side of the square. If we know one side, we know every other side because it is a square. And then we want to find out also the area. Same thing. If we know one side, we know all the sides. And it's finding a square's area is just side times side. So, have to decide what kind it is. Again, it's a square, which means all these sides are the same, meaning this has to be 45 everywhere. So, across from 45 are our s's. Across from the 90, because it's a square, is s radical 2. There's our information. S radical 2 equals 11. So divide both sides by square root of 2. Can't keep it there. So s equals 11 radical 2 over the square root of 4. S equals 11 radical 2 over 2. Yuck. That's alright. That's our s. I'm going to go ahead and plug it in wherever we see our 2, our s. We know all sides are the same. Okay, so there's our s. That's, again, always the first part. So we know every side is 11 radical 2 divided by 2. Not the prettiest number, but it doesn't matter. We have to deal with it. So to find the perimeter, we're going to go ahead and take 4 of those, because we need we can do, yes, we could add that 4 times, but it's much easier just to multiply. So for those, the way you would multiply this is, think of it as 4 over 1 times everything. So that becomes 44, outie times outie, leave the innie alone. 44 radical 2 over 1 times 2 is 2. We can reduce that, actually. 44 divided by 2 is 22 radical 2, and that is feet for our perimeter. Area actually might be a little bit easier and might come out to a nicer answer. The way we're going to find area is simply doing 11 radical 2 times 11 radical 2 over 2. So both over 2. And we'll do this one step at a time. And again, it's going to work out pretty nicely if I looking ahead okay. So that becomes 11 times 11 is 121. Square root of 2 times square root of 2 is square root of 4. Over 2 times 2 is 4. 121 over 4 cannot be reduced. One's an odd, one's an even. Okay, that's not going to work there. But we could make this 121 times 2 over 4. Square root of 4 is 2. 121 times 2 is going to give us 242 over 4. And if I'm thinking of this correctly, we are actually going to be able to take that and divide it, and works out nicely. No, it doesn't. It comes out to 60.5. So we will just leave it as, I'll take 60.5 here. 60.5 feet squared. So not the nicest numbers, but the steps aren't too bad here. Number 6. Again, pay attention to the words that are given to you. An equilateral triangle. So there's your equilateral triangle. We know that equilateral, lateral means sides. Has a perimeter of 18 centimeters. Okay. Find the length of the altitude. So that's going to be this guy here. And then find the area of the triangle. Okay, so first step is thinking about what we might know here. Well, it's a perimeter of 18. Every side is the same. 18 divided by 3. That's going to give you 6. 6, 6. Ooh, that's a little creepy. Now we also need to figure out a couple different things. You can if you wanted to, since you know altitude has a 90-degree angle here, you could either split this up into 30, 60, 90s, or you could use Pythagorean theorem, because you know it's an equilateral triangle, which means this is 3, this is 3. It's up to you. I'm going to go ahead and do 30, 60, 90s, because that's what we're practicing. We want more practice is a good thing. So we know it's equilateral triangle, which means 180 degrees divided by 3. Each angle is going to be 60 degrees. So it's 60, 60. Up here is 60 cut in half, or 30 and 30. Across from 30 is S. Across from 60 is S radical 3. Across from 90 is 2S. Here's our information. So we're going to say S equals 3. That's done. Now we're going to go ahead and plug that back in here. So 3 radical 3 is your altitude. So that's not too bad. 3 radical 3, what is this, centimeters? So we've done that, find the length. Now find the area, okay? Might have been a while since you've done area of a triangle, and we'll hit on this more, but base times height divided by 2, or 1/2 base times height. It's the same thing. Base times height divided by 2. So our base of this triangle is going to be 6, because that's the entire bottom side. So we have 6 times our height is 3 radical 3 all over 2. Area equals 6 times 3. That's an outie times an outie is 18 radical 3 over 2. So our area is 9 radical 3 centimeters squared. And the last one. Find the exact and approximate length of AB. So we want to find this guy right here. Okay. We know A to this bottom point is 40. So if we can figure out the entire thing, we know what kind of, or how long our AB is. We could take that 40 away. So now we're looking here. You have 2 sides and a 90-degree angle. I threw this in here for a reason. two sides 90-degree angle. You're not using 30, 60, 90. You don't even know if this is 45, 45, 90 or 30, 60, 90, and you can't guess because you don't know. So, although I suppose you could use 45, 45, 90 because you know both sides are 55, so it'd have to be 45 and 45. But let's go ahead and do Pythagorean theorem just to change it up a little bit, which means across from 90 would be C. A and B don't matter. And we know Pythagorean theorem is a squared plus b squared equals c squared. So that's going to be 55 squared plus 55 squared equals c squared. So that's going to be, I got to get my calculator out. 55 times 55 or 55 squared is, holy cow, 3025 plus 3025 equals c squared. So that's going to give us 6050 equals c squared. Let's hope that works out nicely. I'm using my phone because I forgot my calculator at school, like you guys do all the time. So let's see how we do this. 6050, and we take the square root. You guys probably have already done it. Oops, you can't do it. Doesn't work out very nicely. So we're going to have to take chunks out of it. Little factor tree. Let's break this up. I know we can divide that by 50 for sure because there's a 50 in it. So 6050 divided by 50, 121. That was a good number I think I picked there. So that breaks up into 50 and 121. 50 breaks up into, let's go 2 and 25. 25 breaks up into 5 and a 5. Over here, that breaks up into 11 and 11. That's why it turned out to be pretty nice. So, ends of our branches, we have a pair here. We have a pair here. We have a solo guy right there. That's going to stay inside. So our C is equal to 11 comes out. A 5 comes out. So that's 5 times 11 is 55. Inside is the square root of 2. So that's this entire length. Let's see if I can draw this. 55 radical 2. And now, if that's the entire length. To get rid of that 40, you guys would just say, oh, let's just subtract it. So the length of AB is going to be equal to 55 radical 2, take away 40 inches. And that's exactly how you'd write it. You can't combine them, so you just leave them just like that. Alright, I will see you guys on Monday. If you want to, we're going to work on this group work on Monday, and if you want to be an expert and work ahead, you think you have this down, then you can help other people in your group. That works. So if you want, you can work ahead. This will be what we do on Monday. Whenever you don't finish, will be homework. So feel free to go ahead and move along. Adios.